Hello and welcome. This is Dr. Himayatullah Khan. In this video, I am going to show you how can we select leg structure. In various time series model, leg selection plays an important role. So we must know which is the most appropriate leg structure for a particular model. I start with an example of my data in which I have four variables: consumer price index, industrial production, money supply, and treasury bill. So first of all, I would like to open all the four variables as a group, and when I open them as a group, uh, I will estimate var, and in var estimation I will get this dialog box, and here I will write the exogenous variables. So my four variables are CPI, IP, M1, and T bill. Now let me tell you that by default the leg interval for endogenous variable is here from 1 through 2. So it will take two legs. Let me start with the 1, and I instruct the model that there should be only one leg in the model. So by pressing OK, I will get my, just a moment, I made a mistake. Let me do it again, please. This is quick estimate var, and here I will write CPI, IP, M1, T bill. So this time it should come. So yes, I have this vector auto regression estimates, and these are the four equations, and they are independent variables with leg 1. All the variables have been used in this as leg 2. Okay, let us suppose that there are two legs. Now according to leg selection criteria, I can use either a Kaike information criteria or a Schwarz criterion, and the condition is that I will select the model in which the Akaike information criterion is the minimum, or the Schwarz criterion is the minimum. Let me continue with Akaike information criteria, and I will note this value, which is 9.9637. So remember, this Akaike information criterion value is when I have used two legs in this var system. Now let me re-estimate var, and I will write name of the variables again: consumer price index, industrial production, M1, T bill, and this time instead of 2 I will write 4 because I want to use legs from 1 through 4, and by pressing OK I will get another vector auto regression estimates of the four equations. Now this time you see each each variable has been used with its four legs: leg 1, leg 2, leg 3, leg 4. Similarly, the industrial production has four legs, money supply has four legs, treasury bill has four legs, and below here this is the Kaike information criteria, and the value here is 9.68526. So I will also note this value because I will then compare which model has the lowest Kaike value. Now let me re-estimate var. First I will write consumer price index, IP, M1, T bill, and here I will write now this time 6. So using 6 legs I will get another vector auto regression estimates, and if you look at this, now this time each variable has been used in with 6 legs, that is CPI with 6 legs, IP with 6 legs, let me see, money supply, that is also taken in 6 legs, and treasury bill in 6 legs, and here This is the Kaike information criteria, and it has the value of 9.6633. So I will also note this value. Now going back to var, I will estimate this again. M1 T bill, but this time I am using 8. So I used 2 legs, 4 legs, 6 legs, and 8 legs. So this is my model with the legs. Now in this vector autoregression estimates, I have 4 equations, and in all the 4 equations, each variable has been used with 8 legs. This is CPI from leg 1 through leg 8, and similarly IP from leg 1 through leg 8. Money supply and treasury bill, all the variables have 8 legs. And here let me see the Akaike criterion value is 9.6044. 9.6044. So I will note this also, 9.6044. 9.6044. 9.6044. uh, let me continue with this, and CPI IP M1 T bill, and this time let me use 10 as a leg. So let me see what happens to a Kaike criterion value. So this time the legs are 10 for each variable, and this is 9.59. Since this is a monthly data and the total observations are 925 or 24, so it requires that I must take more legs. So this is 9.593. So for 10 legs, for 10 legs, it has a AIC value equal to 9.59. Let us suppose I stop here and I assume that if I use 12 legs, then the AIC value increases. So now I must compare these values. So when I use a Kaike for 2 legs, the value is 9.96. For 4 legs, it's 9.68. For 6 legs, it is 9.66, and for 8 legs, it's 9.60, and for 10 legs, it's 9.59. Let us suppose that if I use 12 legs, then the value of Akaike information criteria increases. Then I will stop here, and this is the criteria. And using the lowest Akaike information criterion, I will use 10 legs in say cointegration, var, vector error correction, and so on. So this is very important because whenever we do cointegration test or var or vector error correction, we need to use optimal leg selection, and this is one of the ways how can we select leg structure for our econometric models in time series.